What we have is a universal statement, a statement that says some property applies to all objects in our universe of discourse. In this case, the property is being A and being C. Statement 1, or premise 1, tells us that all things in our domain of discourse have the property of being both A and C. So we can use universal elimination to substitute in a name for some object of our domain in our domain of discourse, and we will know that that object has the universal property because everything in our domain of discourse does. So this rule is stated here. Notice some details about this rule, the universal elimination rule. It tells us at step M that if we're given at step M some sentence for all x are phi, then in sentence phi, we could substitute in some name, some constant that stands for an individual object, C in this case, for x. And this will be our application of our rule. We can say via universal elimination, we replaced the variables in this universal statement given at step M with names. In this case, the name is C. The single box here means that all of the instances of x get replaced by C. Again, you do not draw this single box in as you are working the proof. Instead, this is telling you what you can do. And what it's saying is replace all x's with a constant of your choice, in this case, constant C. So our goal in this proof is to derive the conclusion A is C. So how do we do this? Well, the way in which we do this is we simply use universal elimination to substitute in the name A for some object in our domain of discourse. So we say that A is A and A is C, right? This will be an application of the universal elimination rule. And again, all we have to cite there is that universal statement given at premise 1, which shows that all things in our domain of discourse are A and also C. So it follows then that A must be A and C. And then from this, we can derive that A is C, and that gives us our goal. Okay, that's your proof using universal elimination.